we want to cover in the next hour. First, we will make a short preparation to come to the point where we left off in the last seminar, and where we can start to show how TESSY handles changes in the interface and how stub functions are implemented and such things, which is then the big topic in the second part of the webinar. And we will close with a shorter part where we handle the point of pointers which are passed to stub functions. And yeah, I think this will take an hour or so. I have a little bit more prepared, but I don't think we have time to do this. Okay, let's start with the preparations. I have already started TESSY, and I think you are familiar with TESSY. It's based on Eclipse, and you have several perspectives which are used for different tasks of unit and integration testing. And testing starts by making up such a folder structure here. I have already made a test collection and a folder beyond this test collection, and the real work starts by defining a new module, and I give it a name. And the first thing is I need to assign a C source file in which my test object that I want to test is in, and I browse for the C source file, and I take this one here. It is called isValueInRange.c, and I open it. I have prepared something here. I will use this file isValueInRange.c, and first of all I would like to give you a short overview into this test object. This here is a function we want to test. Our test object, it's named isValueInRange, and it solves a very simple problem to find out if a given value is inside a range or not. The range is given by a start value and a length, and yeah, that's very easy. And if I go back to the overview, I can let TESSY analyze this module. This means TESSY finds out which test objects are in this C source file, and TESSY also determines the interface of these test objects. We see here we have only one test object, one C function in this C source file, and the interface of this test object is depicted in the interface editor perspective. And we see here, because we have a very simple test object, we have no external functions, no local functions, no external variables, no global variables, but we have two parameters. The first parameter is a structure. It depicts the range. It consists of two components, a start value and a length. And the important thing here is that TESSY has determined that the passing direction of both of these components are in. In means into the test object. So these variables are read by the test object, and therefore I have to specify values prior to the test for such kind of variables with a passing direction in. Also, the second parameter, the variable v1, is input. v1 is a value from which we want to know if it's inside the range or not. The only variable with the output direction is here the return value of the test object. If there is a return value and it's no void function, the return value is always out. Okay, this gives us the structure. The interface gives us the structure of a test case, so we can go ahead and try to specify test cases. And we have here this column here, and usually you can now enter test cases manually, test data manually, but I would like to shorten this. I would like to import test data from an Excel sheet, and if I do so, I get immediately 9 test cases. These test cases all have a common value for the start of the range. It's 0. They have all a common value for the length of the range. This is 100, and the value v1 is incremented from 0 to let's see, from 0 to 8. And because the start value is 0 and the length is 100, so 0 is inside the range, 1 is inside the range, 2 is inside the range, 3 is inside the range, and so on. Every value is inside the range. But for one test case, the second one here, a wrong expected result is specified. Here no is specified, and this test case will return yes, as all the others do, and therefore this test case will fail. I can now execute the test cases. And all test cases pass except the second one, which gives a failed result because I have specified the wrong expected result. Okay, this is the end of my preparations, and now I come to the second point, the interesting point. We exercise now with external variables and such kind of things. For this, we change the test object source file. For instance, I can say we have here the variable v1, and I can rename this variable, for instance, to the value v2. And because I have here an Eclipse editor, all occurrences of v1 are changed to v2. And I can also move ahead and, for instance, delete this parameter here and have now v2 not longer as a parameter but as a global variable. I need to delete the comma here, and I even can, that's dangerous a little bit, I can change the name of my text object. So now I have changed a lot of things, but actually my test cases still should hold because I have not changed the semantics, the behavior of my test object, just the syntax, the name, and such things. If I go back to the overview perspective or to the test data perspective, it looks like I can re-execute my test cases, but this will not be possible because if I click on the play button here to execute the tests, TESSY again analyzes the C-source module, and TESSY finds out first that it appears for TESSY that if the old test object was removed and a new test object has appeared, and TESSY needs confirmation about this in the interface data assigner perspective. And the interface data assigner perspective is the perspective here. And in this interface, in this perspective, I can see the two interfaces side by side. I just drag and drop the new test object and the old test object, and now I see that the interfaces side by side. You see that these things which are equal are marked by a green tick mark, and the things that are different are marked by this red point here. And the only difference seems to be that in the old interface there is a parameter named v1, and in the new interface there's a global variable named v2. And now I can go ahead and simply drag and drop this v1 to v2, and this tells TESSY, please take all the values which were used previously for v1 and use them now for v2. And if I have done so, all the tick marks are green, so I can commit my changes. TESSY is now reusing this test data and adapting it to the new test object. This means if I switch to the test data perspective or test data view, I see all my test cases, but you see that v1 is no longer present, but instead of v1, global variable v2 exists. And the important thing is v2 now holds all the values which were previously assigned to v1. So my test cases are preserved, and I can now re-execute my tests, and I expect the same results as before because I have not changed the behavior of my test object, just the interface, the name of the test object, and so on. And actually this is the case. All the tests give the same result as before. we can go one step further. I can go to the source again, and I can write the keyword extern in front of the definition of v2, which now becomes a declaration. And I save this, and I go to the test data editor, and I try to execute my test cases. TESSY again analyzes the interface, and TESSY tells me, okay, the interface has changed and I have to make a reuse operation in the IDA perspective. I go to this and I see here that now the global variable v2 as an external variable has appeared in the new interface. I say this is what I had expected and I commit it, and now I can go to the test data editor again and I can try to execute my test cases. At the moment it looks good, but the test case execution will fail. Maybe you also already know the reason why it has failed. The reason is that we have no definition of v2 at the moment. We have declared this external, and this means somewhere in the application we need a definition of v2, and we have now generally two possibilities to solve this problem. The first one is we can add an additional module, a C-source module, an object, to our test object, to our test application, and this additional module could hold a definition of v2. This would solve our problem. The second solution is we can direct TESSY to provide a definition of v2. And because we would like to do unit testing in the first place, and unit testing means only one function on the test and not several C-source modules, I think this is the way to go at the moment. And how do I define such a variable in TESSY? I go to the interface editor, and you see here that v2 now is not longer listed under the global variables but under the external variables, and under the external variables I have the possibility to use the context menu and to say define variable. And if I do so, the blue point here will be filled with blue, and this means now TESSY provides a definition for v2. This means if I save this and go back to the test data editor and I re-execute my test cases, now the test will pass because TESSY has provided the definition and all tests behave as before. Okay, this was the handling of external variables, so I can define memory for an external variables. Let's now go to the topic of stub functions. Stub functions come into play if we call another function from within our test object, and I just implement such This means I call here a function which is called absolute, and this function is passed the length parameter of the structure, and the return of absolute is assigned again to the same variable. So I give this variable value in absolute as a parameter, and the return value is assigned to this variable. So that's more or less everything, and I need to provide a declaration. This is a declaration of this function, and now I can try to test this. If I go to the test data editor, it looks good, and I can try to execute the tests, but it will not work. First of all, TESSY has again identified that the interface has changed, and if I go to the test data assigner view, I see that the problem here is that now an external function is identified. I can say, okay, I know this, and I that's okay for me. I commit these changes, and now I can go again to the test data editor and make a second try to execute my test cases, but this will also fail for the same reason, more or less, as that the other test has failed, because I have no definition of absolute. And similar to the case with the external variable, I have also two possibilities to solve this problem. I can tell TESSY to provide a stub function, or I can provide the definition of this function by myself. To show this a little bit, I have here this this picture. This is a possibility. I can let TESSY handle this problem by providing stub function. There are two kinds of stub functions available. One kind of stub functions provide a possibility to check the value of the parameters that is passed to the stub function, and provides the possibility to specify a return value from the stub function back into the test object. This is one kind of stub function, and I will start to show this first. There's another kind of stub functions which allows the user to edit the body of the stub function to provide C source code and such things. I will show this a little bit later. So this green part here is when TESSY takes over the handling of such a called function. As I said, also I, the user, can handle this by providing, for instance, C source code where absolute is implemented in, or providing a binary code, an object code where absolute is implemented in. This could be a library or whatever. We will see this later. We start by providing the kind of stub function which allows us to check the parameter value and allows us to provide a return value specification. These functions are called advanced stub functions in the terminology of TESSY. I do provide, or direct TESSY to provide stub functions again in the interface view. I see here now that an external function is listed in the section external functions. It's my function absolute, and I can again use a context menu to say create advanced stub function. It does not differ if I select for all test objects or for current test object, because we have only one test object, so it makes no difference. If I direct TESSY so, the interface is extended by two variables. The first variable is the return value of the stub function, and the return value has a passing direction in, because the return value is passed from the stub function to the test object. And the second variable which is introduced is the parameter value, which the parameter is passed from the test object to the stub function, and therefore the passing direction is out, because the passing direction always is seen from within the test object. And because we have now two new variables, if I go to the test data editor, my test cases are now not executable, because I need to provide values for the additional variables first. I have here the output value, which is the value of the parameter, and we know that in all test cases the value 100 is passed to the test object, and the test object simply takes this value and passes it to the stub function. And therefore we can assume that in the first test case 100 is passed and specifies the value 100 as expected result, and we can assign this value to all test steps. So if we do so, now all test steps expect that the value 100 is passed from the test object to the stub function. And here we can specify the value of the return value from absolute, and we can say, okay, if absolute does what it should do, what the name tells us, so if I pass 100 in, so I would get 100 back again, and if I do so, I can specify this for all test cases, and now I have solved the problem of uninitialized variables. All variables now have have a value, and now I'm able to re-execute my tests. So I could do so. So the call to absolute is more or less transparent, and all test cases should give the same result as before. And to prove that there's really some testing done, I can, for instance, change this expected value of 100 here to, say, 40, for instance. And this obviously will not be the case, so this test case number 4 will fail because we have specified the wrong expected result for the parameter value. And I also can, for instance, specify here for the test case number 6 a new length, not 100, but for instance 3. This means the start value still is 0. The new length now is 3, and this would mean 5 is not inside the range, and we will get not the expected result yes, but the result no. And if I do so, hopefully I will have now 2 additional failed test cases, and this is the case. Test case 4 and test case 6 now fail as expected. The next question is what would happen if I call this stub functions 2 times or more than 1 time. Add a line here. I do want to use now the start value of the range. So I do the same as with the length. I take the start value, I put it as a parameter in my absolute function, and I assign the return value of the absolute function to the same variable. And yeah, what will happen now? I save this, I go back to the test data editor, I try to re-execute my test cases. TESSY analyzes the interface, but now nothing has to be done. The tests run, and I get a lot of failed tests, and this is clear what has happened, hopefully, because both calls of the stub function do the same passing and checking and returning. So returned is always 100. This means the start value and the length is now 100, and this means no value of v2 is inside the range. Therefore, most of the test cases fail, except these which have the wrong expected result. But this is not my final intention. I would like to specify for instance 2 different values for the calls to absolute, and I can do this by using these curly braces, and I can say at the first call of absolute, where the start value is passed as a parameter, I expect 0, and in the second call to absolute, where the length is passed from the test object to the stub function, I expect the value 100. And if I do so, I can use to do so. I can use this notation, and I'm also able to assign this to all test cases. So now I have for all test cases specified. For the first call, I expect 0 as a parameter value, and for the second call, I expect 100. And similar, I can go ahead with a return value of absolute. I can specify that for the first return I want to return the value 0, and at the second call of absolute I want to return 100 to my test object. And I can also assign, I have now copied this, and I now can assign this to all test cases. So now if I re-execute the tests, most of the tests should pass. So we are now back to our initial behavior. The test objects behave good. And to prove that there's really a check is going on, I can, for instance, change the expected value for test case 4 for the first call to absolute to 1, that will make this test case fail. I can change the expected value of the second call to 99. This also will fail. I can, for instance, reduce the returned, or I could increment the start value from not return 0, but for instance 10. This will mean 5 is not inside the range because the range is now from 10 to 110. And I can maybe in the 7 test case I could reduce the length to 3. This means 6 is not inside the range because the range start at 0 has now a new length of 3, and this 6 is beyond the range. So if I re-execute the tests now, you will see that these tests which I have manipulated the test data will fail. We have now a lot of failed test cases, and you see that, for instance, with test case number 4, the reason is that 0 and 100 has passed, and also here 0 and 100 has passed, and only one element matches the expectation. And we see here that it's outside the range because we have manipulated the start value, and also we can see here in the 7 test case that we get no because we have artificially reduced the length of the range. So this is how several calls to a stub function can be handled, and how different values can be specified for each call. If there are more calls than values specified, this means the last value is taken all the time, and if you have specified more values than actually calls occur, you will get a warning message in the console window. With stub functions we have another possibility of checking TESSY features, what is called call trace, and I can specify a call trace on the left-hand side. I have the expected call trace. On the right-hand side, I have the functions which could make up the call trace. At the moment, I have only one function. The one function is a function absolute, and I know that in all the test cases, absolute is called 2 times. And now I have specified that, at least in the first test case, I expect absolute to be called 2 times, and I can assign this expectation to all test steps. And if I do so, all test cases get this expected call trace of 2 calls to absolute. And if I do so and run the tests, we will see that this expectation is met for all test cases, and therefore we get here this row of this column of green tick marks, because in this column the call trace result is specified. We are now able, for instance, for the 3rd test case to specify a different call trace. For instance, we can say in the 3rd test case we expect 3 calls to absolute, and this test case will fail because of this wrong expected result. And for instance, for the 8th test case we can specify that we only think absolute is called 1 time. So if we re-execute the test now, we should find out that 2 other test cases fail, but they do not fail because of wrong expected return values. They fail because of the call trace is not met. We can see, for instance, here what happens to test case 3. We expected 3 calls to absolute, but absolute was only called 2 times, so therefore this call trace check failed, and then we can go to the call trace of test step 8, and we see here that we have expected 1 time, and actually the actual value is 2 times calls, two calls to absolute. We can make all test cases fail if we introduce, for instance, an additional function, for instance, we simply declare an additional function, and we call this function in the middle of the two calls to absolute. If we save this and if we go to the test data editor, okay, I confess first we have to adjust the interface, so TESSY will find out that the interface has changed because we now call an additional function. I have to go to the interface data assigner. I have to confirm that I expected such a call to an additional function. I confirm this. Now TESSY adjusts the interface. I go to the test data editor. Be executed because I have no definition of this fx function, and therefore the linking of the test application will fail, and I can remedy this in the test interface editor by such creating a stub function for it. And now I think everything is in place to execute these tests, and if I do so, the call trace will fail for all test cases, because in the call trace nothing is specified about have failed with respect to the call trace. And yeah, we can also see the call trace, for instance, for test case 1. You see here we expected absolute to be called 2 times, but actually it was called 1 time. Then an unexpected call to fx was recorded, and then the now unexpected second call to absolute occurred, and this is the case with all test cases, and this fx makes the whole call trace fail. So this is what was on my plan to show you with advanced stub functions. You remember maybe that there is another possibility of stub functions, the stub functions with user code, and I will now disable this stub functions, this advanced stub functions, and we'll go back to the normal stub functions. And first I delete this this call to fx to make the test object a little bit simpler. I save it. I let TESSY analyze this. This will of course mean that I have to go to the interface data assigner, and I have to assign the test object, and here fx has disappeared, was present in the old interface, is not longer present in the new interface. That is exactly what I expect, and therefore I commit this, and then I go to the test interface editor, and then I disable this advanced stub functions, and I go ahead simply and create a stub function, which means a stub function where I can provide user code and do other things. I save this, and if I now go back to the test data editor, a lot of my additional variables are disappeared, and the test cases are now much simpler. And additionally, I will delete all call traces, and I apply this to all test cases. This means if I save this, all call trace will disappear, because at the moment I do not want to check the call trace. But what I want to do is I would like to specify a stub function, and I'm now able here to enter the body of a stub function, and for instance I can just enter return 3, for instance. This would mean every time when absolute is called, it returns 3. We know that absolute is called 2 times. The first time with the start value of the range, and the second time with the length of the range, and we will see how this affects the outcomes of our test. We save this and close this, and now we run the test, and yeah. used the wrong place for the definition of this stub function, because I need a stub function for all the test cases, not only test case 1. Okay, that's now the results that I expected. Remember, we have now the start value 3 and the length 3 for all test cases. This means from test case 4, 3 is inside the range, 4 is inside the range, 5 is inside the range, and 6 is inside the range and 7 is not inside the range. Due to a programming error in the test object, 4 values are inside the range, 3, 4, 5, and 6. Okay, so now we have the same return value for both goals to absolute. Even with this kind of stub functions, we can specify what should happen in the first call and in the second call. But this needs a little bit of programming. We can have a stub function code like this. This means we check the number of the call, and this is in a variable provided by TESSY. This is a variable TS call count, and this gives us the value how often our stub function was called. And this means if the value is 1, it was called for the start value, and then we specify to return 3, and if it is called a second time, we know it's called for the length, and we specify the return value of 2. And we can take this and replace this implementation of the stub function, which is valid for all test cases, with this code. We have here a special value for this first test case, but I would like to use this, for instance, for the 8 test case and specify here a return value. In the 8 test case, the value is 7, and this means start value and length is 7, and 7 is inside the range, so I assume the 8 test case to pass. And I also assume that now not longer 4 test cases pass in the middle, but only 3, 4, 5, and 6, and not longer 7, because we have shortened the length for all test cases except the 8 to 2. And this is now the case, as you can see here. I can make this a little bit. So we have now only 3 test cases which pass, not 4, because we have reduced the length here. Okay, back to this PowerPoint slide, you see here that there is a lot of other things available. We have now learned what TS call count can do. There's also a possibility to find out what is the number of the current test case, what is the number of the current test step, and there's also the possibility to use this kind of evaluation macros, how they are called. This allows you to evaluate values of variables inside a stub function, and this will add to the overall result of a test case. And how to use this is explained here. I have the same code for the stub function, but I have introduced 2 evaluation macros. An evaluation macros always has 4 parameters. The first parameter is a name for this evaluation macro. This is for instance used in the test report, so that you know what this evaluation macro should evaluate. The second parameter is a variable name. In our case, the parameter that is passed from the test object to the stub function. The parameter has the name param, and the third parameter to an evaluation macro is the evaluation mode. It could be all the possibilities that are possible in C, so you can say greater than or smaller than or unequal or whatever. And in the fourth parameter, we specify the expected value of this parameter here. So this means if we use this for the start value, we know in every test case the start value is 0, so we expect that all this evaluation will be pass. And this evaluation macro here is quite similar. It also checks the parameter value, but then the length value is passed, and we know that the length is always 100, so this will again pass. Please notice here we can also specify a format. Yeah, and I now take this enhanced code of the stub function and put it instead of the existing code. And we have now the stub function code here inside. And let's see what happens if we execute the test cases. So we see here now a column with all tick marks in green. This means for all the test cases the evaluation macro passed. So and it's clear that this is the case because in all test cases 0 is passed as start value and 100 is passed as length. And to check that the evaluation macros work, we could, for instance, pass here the value 1 and use here the value 99. So these both test cases now should fail because the evaluation macros of these two test cases should fail. And we can prove this by executing the tests. And we see that the expected result is still green, but we see that test case 4 and 5, the outcome of the evaluation macros is red, and this is also very obvious in the test report. Just another point, we have specified a special stub function for test case 8. So if we changed the overall stub function, the special stub function was not overwritten. This means a stub function for test case 8 does not have evaluation macros inside of it. So if we check this, we will see that the stub function for 8 is different, for test case 8 is different than for all other test cases. It just has the return 7 and not this evaluation macros and not the check for the number of the call. I said the evaluation macros are quite visible in the test report, so now I create a test report in PDF format. I have to take this to the screen. I have now here a test report. We have 9 test cases, all of them failed for different reasons. We see here the stub function bodies. You see that test case 8 has a different body than all the other test cases. And you see here the reason why, for instance, test case 1 failed. This is because the outcome is wrong. And you see here the evaluation macros. For test case 4 and 5, they fail. For instance, here you see that for test case 4, the expected value in the evaluation macro was 0 for the start value, and the actual value passed by our test data is 1, and therefore this failed. And also here we see in the 5th test case that the length was not as expected. We expected 99 and actually 100. We expected 199 was passed. So the results of the evaluation macros are also present in the test report by TESSY. Okay, this is what I wanted to show you about the user stub functions. In this screen here, you see that we are now going to shortly present the possibilities you have by providing source code for the function or object code for the function. To show you this, first I have to despecify the creation of a stub function by TESSY. This means at the moment the tests will not pass because if I try to execute these tests, it will not be possible to link the test application because no implementation of absolute is present, and therefore this fails as always. No, with undefined reference to absolute 2 times. And to remedy this, I now follow. I will now show you how to add a CSource module to our test application, and I do so this by simply browsing for an appropriate CSource module. I have one prepared here. It's called absolute.c, and I just open. I add it to the TESSY module, and now the interface again will change. If I advise TESSY to analyze the module, TESSY finds out that we have now 2 test objects, and the old test object isValue in range is not longer executable because the interface has changed. We need to go to the IDA perspective. I drag and drop this function in this view, and I see now the old and the new interface side by side. In the old interface there was an external function called to absolute. This has now changed to a local call to absolute. A local call means TESSY knows the CSource code. It does not depend if it's in the same CSource module or not, and I confirm this because I expected this, and after I have confirmed, I can execute my tests in the test data editor view. Now the test application can be linked because I have added a function which with the name absolute. It's inside this absolute.c, and all my test cases pass besides the second one, which has a wrong expected result from the beginning. Maybe I should prove to you that absolute does what it is supposed to do. I could, for instance, provide the value -100, and I could also provide the value -1, and if I execute the tests need still to be passed because absolute does what it's supposed to do, and therefore the tests pass. I can, for instance, show you just test case number 4, and I can show you test case number 4 with a just a moment. Okay, I try to show you the second test case, the fourth test case with this defined breakpoint. So I stop in the test object. And I can step inside and I will at some point end in absolute, and you will see it is because of the call trace. The call trace instruments the code, and my problem is that I need to delete this here. And maybe then it works a little bit better. But this is not an important thing what I wanted to show to you. Just again a try. No, it has not improved very much, so let's skip this. I wanted to show you not only how to provide source code for the function which is called by our test object, I also want to show you how to write binary code. There are also two possibilities. I can simply provide an object and link it to our test application. This is the first thing I wanted to show to you. I do so in the first. To show this, I need to delete this absolute.c from the test application. This means the interface has changed and I need to assign it in the interface data assigner again. You see here now it's completely different. It's this C source module. I confirm this, I commit, and now I can try to run the tests. This will fail because there is no implementation of absolute present. So we get the usual linker error here, and I can remedy this by providing an object. And if I go to the module properties, I have an additional possibility to provide options to the linker, and with the GCC that I'm using now, it's just a possibility to provide an object on the command line to the linker, and then the linker will link this object to the test application, and in this object here is an implementation of absolute, and therefore if I save this and go and try to re-execute the tests here, we will see that the test application can be linked and that all the tests yield the expected result. This means also that even the tests which negative length and negative start value can be give their expected results. This means this implementation of absolute does what it should do. And there's also a possibility to a second possibility to link to an object to a test application. We have seen here it especially for one module, but we can also have a solution where all tests that we do or all modules that we create would link such an object to our test application. To show this, I first delete this linker option here. This means the test will now not longer run. If I can now not rerun the test because I have deleted the object file, and I can remedy this by selecting for the module another execution environment, an execution environment which I have set up in a way that absolute.o is linked to the test application, and if I use this I can execute the test. And such an execution environment can define variables or use special linker options or use special embedded compilers or whatever. If I use such an environment, all my modules that I create from now have this special features which I have defined for this environment. It's not the topic of this webinar here to show how to set up an environment. I just have shown you how to use such an environment. You see that I am now able to execute all the tests and all the tests pass, and this environment more or less does the same what I have done especially for the C source module by specifying absolute.o. Okay, now I come to the end. I just want to show you how stubs with pointer can be handled. It's a very short topic. I hope I can finish it in 10 or 15 minutes. I hope you have time for it. This is a different example I create a new module. I name it Stub with pointer. I select a C-source file for it. I take this one here. And first of all, I would like to show you what's inside of this C-source module. It's only one function. It's called func, and it calls another function which is called increment. And the jumping point is that a pointer is passed from func to increment. And I would like to show you how this can be tested with TESSY if we pass a pointer to a stub function. This pointer here is a pointer to a byte. Byte is defined to be an unsigned character. Okay, let's go to this overview perspective. If I click on here, TESSY analyzes the C-source module, and I now can see that we have one test object, it's func, and I can see the interface, and I see that TESSY has identified that an external function is called this increment function, and I now can create an advanced stub function for it. Now I have two passing directions. One, this is a passing direction for the pointer, and this is a passing direction for the target of the pointer towards the pointer points. And yeah, I need to change this because I first wanted to create a test case where the stub function returns a value in the target value of the pointer, and therefore I have to set the target passing direction to input. I save this, I go to the test data editor, and I see if I create a test case that I have three fields. This input field here is the parameter value to func, to my test object, and this is the return value of my test object. And if I fill in here, for instance, 5, I would expect to get 6 back, because I expect that this increment function increments the values that the pointer points to. What I also need to do is I say create pointer target value, and if I do this, TESSY will create a memory area in the size of a byte, what the pointer points to, and will allow me to specify which value to return by this pointer to the test object. So if I do so, I'm asked if I need only one element or an array of these elements. I only need one element, and if I do so, I get here an additional field where I can specify the values that I intend to return by the pointer from the stub function to the test object. And I specify 6 because I need to return 6 to my as expected as return value of func. And if I execute these tests, you see that it has worked. So the return value of the test object is what was returned by the pointer. If I specify a different value here, for instance 7, you will see that the test will not longer pass, because the return value of the test object will now be 7. Okay, I hope this is clear. I go back to 6 and rerun the test. And I now want to change the interface a little bit. I have only specified the target passing as in, because I want to return a value to the test object. Now I change this to in-out. This means I also want to check which value is passed by the test object to the stub function by the pointer target. And if I do so, and I save this and go to the test data view, I see that there's an additional field now in the test case, and this is a field where I can specify what I expect, which value I expect, which is passed from the test object to the stub function. And I use the value 5 because I know that 5 is passed to the test object and passed to the stub function, and 6 is returned, and then 6 is also returned by the test object. If I run this, I should get both fields green. What is the case? And for illustration, I just wanted to show you here quickly this picture. So this test case enters 5 to the test object. The test object passes 5 as a target of the pointer to the stub function. The stub function returns 6 as a target of the pointer to the test object, and finally the test object returns 6 as its return value, and this is what happens in this test case which we have seen. Let's make another change, important change to the test object. Let's change the type to what the pointer points from byte to void. This will change a lot of things because now TESSY does not longer know to what type the pointer points to. And if I save this, and if I direct TESSY to analyze the module, we will see that the interface has changed again. You see here that here is the unsigned character as target of the pointer, and here we have a void pointer. That's a difference. The new interface has a void pointer. This is what I expected, therefore I commit this change. But if I now go to the interface editor, I see that set to what the pointer points is now set to irrelevant because TESSY does not know the type to what the pointer points, and because it's irrelevant, I cannot change it to in or out or whatever, and therefore I cannot use an advanced stub function for this kind of parameter void pointers. And to do the same thing that we have done before, I need to switch to the normal stub functions. This would mean the additional variables in the test data editor now have gone away. I have only my input to my function and the output, the return value of the function. And if I run the tests, the test will fail because the stub function that I have implemented now has an empty body, and it does not increment stub function. Sorry, the stub function has an empty body, and this empty body does not increment to what the pointer points, so therefore this test case fails. To remedy this, I need to provide an appropriate stub function body. I have prepared such a stub function body here. It's more than I need. Actually, I only would need this last line where the void pointer is casted to a byte pointer, what it actually is, and then the contents of the target are incremented. So this is what makes 6 out of my 5, which is passed, and I have two additional lines with evaluation macros. The first line checks the pointer itself, and it checks it against 0. It is not 0, so this macro will fail all the time because I pass a valid pointer which is not 0. And the second line here checks if the value the pointer points to is 5. And the problem here is that this special data type byte is used now in my stub function code. I can copy this from here to the stub function code, and so this means my stub function now looks like this. But if I try to execute the tests, I will see that there's still a problem here because byte is not known in the user code. Byte is undeclared. And to remedy this problem, I can add a declaration for this. And the best is I take the line from the source and just copy the line from the source to the declaration section. To the declaration section here. And having this line, I can execute the test case. now it works, and the expected result 6 should now be returned by the test object. So I have now remedied this, and I can check the value, I can check the pointer, I can specify the return value. That's no problem at the moment. The only thing you could say is, do I need to specify every definition I have here? And I say no, it's not really so necessary. To prove use this, I first change the test object code. I delete this line here, and I enable the include line here. I now include a header file, and in this header file is exactly the same line which defines byte as unsigned character. So my test object, for the test object there's no difference, and also for the in the test data view there's no difference. I can execute the tests regardless if the definition is from the header or if the definition, the type def of byte, is in the C source code. But now, so everything works as expected, but now I can delete this declaration. This means it will not longer work because I need this declaration at the moment. So I get the same error as before, that byte is undeclared. But in the situation where the type definitions are included in a header file, I can use a special feature of TESSY which is called enable user includes, and if I tick mark this means that TESSY reads all the header files and gets all the type defs in it and makes it available in the user code, in the stub function code. This means if I have checked mark this, I can then re-execute my test cases because now the type byte is present in the user code. And the test has passed again. So that's what I wanted to show about stub functions with pointers and how they can be handled with advanced stub functions and with user stub functions, what we have seen here. And then I come to the end of the presentation. We have not seen a lot of things, for instance, how arrays are handled, or floating points and graphics and defines and includes and whatever. We have not covered a lot of big topics like requirements traceability or a method for test case specifications, a classification tree method, and we have also not covered how component or integration testing works with TESSY. This is the topic of the next webinar, but prior to this, if you have any questions, you can type them in the chat window and we will try to answer these questions. Do we have questions up to now?
Yes, Frank, we have some questions and you will have some work after the webinar to answer them.
Okay. Okay, I will answer these questions by mail as good as I can. Okay. And as I said, this topic of integration or component testing with TESSY is the topic of the upcoming webinars. For instance, at the same time, there's a webinar in English which might be suitable for you. This webinar is an introduction, so it will also cover a little bit of testing theory. So what is integration testing and what is the difference to pure unit testing? So maybe it's interesting for you. Okay, here is some additional information how to get information on TESSY and an evaluation version. And if you have any special questions about this webinar or this topic, and you can also later write me an email with this question and I try to answer as good as I can. Okay, so that's all from my side. So thank you for attending and I hope it was useful for you. Thank you.
Okay, thank you, Frank, for this interesting and detailed view into advanced unit testing with TESSY. As mentioned, all attendees can ask questions using the webinar tool or via email directly to Frank. Here's his email address, frank.büchner@hitex.de. So we've come to the end, and we say thank you very much to all of you. Goodbye and see you next time.